Hello dear students, today we are discussing a very important topic, relation and function. We'll first discuss relation in general. What do you mean by a relation? It's a link or connection between the two objects. In real life also we see many relations around us like father and daughter, relation of a brother and sister, teacher and a student relation and many more relations, isn't it? In mathematics also, we see infinite number of relations like line m parallel to line n, or number 2 less than number 8, or an equation like this y equals to x plus 7. Yes, this equation also depicts a relationship between y and x. It says y is 1 more than x. Before we go more deep in relation, we must have knowledge of set, Cartesian product, relation, and then we finally go on to functions. So what is a set? We have already discussed this topic in our previous class. Let's recapitulate it. Set is a well-defined collection of objects. You remember? Yes, it's a well-defined collection of objects. So with this knowledge of set, we will discuss the Cartesian product here. Cartesian product is a set of all ordered pairs. For a better understanding, consider an example. Suppose we have two sets A and B. Set A contains three members, three colors, red, blue, yellow, and set B has two objects, pen and book. Now the question is, how many colored objects can be formed using these two sets A and B? Look at the arrow diagram here. In set A, we have three members, or we can say elements, red, blue, yellow. In set B, we have two objects, pen and book. Now, we can have red pen, red book, or blue pen, blue book. Also, white pen or yellow pen, yellow book. So that means in total, we can have 6 objects, or we can say 6 pairs. So whenever we write the Cartesian product of A and B, we write it as A cross B, and we write all the pairs within the braces because it is a set, and these pairs are called ordered pairs. Now why these are called ordered pairs? Because if you see, in every pair, elements are in some order. Like first element of every pair, you can see they're coming from set A, and second element of every pair are coming from set B. So that means in every pair the elements are placed in orders. That is why it is called ordered pairs. This is how we write the Cartesian product of A and B. Now if I ask, write the Cartesian product of B cross A, will answer be the same? No, answer will not remain the same, because when we write B cross A, first element of every pair will come from set B, and second element will come from set A, right? Let's take one more example. Example number 2. We have two sets A, B. In set A we have 3 elements, 1, 2, 3. In set B we have 4 elements, A, B, C, D. Here also, all 3 elements of set A can be paired up with all 4 elements here. Like one can be paired up with A, B, C, D. Write them in pairs like this: 1A, 1B, 1C, 1D. Again, 2 can be paired up with all 4 elements like 2A, 2B, 2C, 2D. And last 3 will be paired up with all 4 elements: 3A, 3B, 3C, 3D. In this way, we get 12 total pairs, right? So, this is how we write A cross B. Now, considering the same example, we will define relation here. So relation is nothing but a subset of A cross B. So that means in relation we'll have order pairs which are derived from A cross B only. We'll describe a relationship between these two sets and we'll derive ordered pairs from A cross B and we write it in relation. For example, let's say R is ordered pairs which begins with odd number. So we'll look for the pairs in which we have odd number as first element. So what are the ordered pairs here in which we have odd number? So 1A, 1B, 1C, 1D. And in last four elements we can see 3A, 3B, 3C, 3D. So these are the 8 pairs in which we have first element odd number, right? So in relation, we'll write all these 8 pairs. Can we have more relation in A cross B? Yes, we can have more relations here, like here R star. Let's say ordered pairs which ends with C. So again look at the A cross B. Do we have pairs in which we have second element as C? Yes. How many pairs are there? There are 3 pairs, 1C, 2C and 3C. So we are going to write these 3 pairs in R star, right? This is how we write the relation in roster form. Next is classification of relation. We have 4 types of relation. One is one-to-one. In one-to-one relation, elements of set A are mapped with elements of set B in one-to-one manner. Like 1 is mapped with A, 2 is mapped only with B and 3 is mapped only with C. So this kind of relation is one-to-one. Next is one-to-many, as name says. One element can be paired up with or can be mapped with many elements in set B. Like here you can see 1 is mapped with 2 elements A and B. Again, the second element of a set, 2 is mapped with 3 elements in set B, A, B, C. Alright. Number 3 is many-to-many. That means many elements of set A can be mapped with elements of set B. Like 1, 2 are mapped with A here. 3 and 4 are mapped with C and E respectively. Fourth is many-to-one. So many elements here can be mapped with 1. So 1, as you can see, 1 and 3 are mapped with A, 2 and 4 are mapped with C. So these are the 4 kind of relations we have. Now coming to domain, range and codomain of a given relation. So what is a domain? Domain is set of first elements of the ordered pair of a given relation. Range is set of second element of ordered pair of a given relation and codomain is the whole second set. Now to understand this, consider the example. Let's say we have set A in which we have 2 elements 2, 3. In set B we have 3 elements 6, 9, 12. Define a relation R from set A to set B as ordered pair xy such that y equal to 3x, where x is from set A, y is from set B, or we can say x belongs to A and y belongs to set B. Now the question is find domain, range and codomain. According to the definition, domain is the set of all first elements of the ordered pair of a given relation. So first we have to find out the ordered pairs here. So first in first set we have 2, 3, right? So 2 can be paired up with 6 here, because if we put x is equals to 2, we get y is equals to 6. So first element of the second set is 6. If we put 3 here in place of x, we get y is equals to 9. So second element will be 9, right? Which has a mapping with 3. So domain is 2 and 3, because 2, 3 are both the elements are mapped with two elements of set P. Now what is range? Range is second elements of the ordered pair. So second elements are 6 and 9, which are mapped with the elements of set A. So these are the two elements. So range will be 6, 9. Next is codomain. Codomain is the whole set B. Now 12 is not mapped with any of the elements with set A of set A. So 6, 9, 12. So these are the three elements which comes in set B. So this is the codomain. Let's do a question based on this. Question says, find the domain and range of the relation R, which is x comma y, such that y equals to x plus 6 by x, where x and y are natural numbers and x is less than 6. Now come on. First of all, we write the ordered pairs in this question. How do we write the ordered pairs? We're going to take x as x natural numbers. So what natural number comes to your mind? What is the first natural number which is less than 6? 1. Yes, we'll put x equals to 1 here. What do we get as y? So when we put x equal to 1, we get y is equals to 7. When we put x is equals to 2, we get y equals to 5. And the last, when we put x equals to 3, we get y equals to 5. So we get 3 ordered pairs in this relation. Now find out the domain and range. Domain is first element of the ordered pair, that is 1, 2, 3. So these are the elements which comes under domain. Range is the elements which are mapped with the elements of set A, that is 7 and 5. So these two elements are coming under range. So this is domain and range of the given relation. Thank you so much. In the next class, we'll discuss functions.